Hi guys, welcome back to the channel. In this video we are going to discuss about flip-flop conversions of all conversions from SR to JK, SR to D and SR to T. So there are total 12 types of conversions. From first conversion is from SR to remaining 3 flip-flops, from JK to remaining 3, from D to remaining 3 and T to remaining 3 flip-flops. So these are the overall all 12 conversions that I can say. In this video we are specified with only the first 3 conversions. So let's start with the first conversion, that is S2 remaining 3 flip-flops. So the remaining 3 sets will be discussed in the upcoming videos. So stay tuned. So these are the 3 things that we are going to see. So first let's see the SR flip-flop conversion to JK flip-flop, then SR to D flip-flop, then SR flip-flop to T flip-flop. So let's get started with the SR to JK. Before seeing the flip-flop conversions, first we need to understand some rules or the flowchart that we can say, or the simple methods that we are going to follow for the flip-flop conversion. So these methods are: the first step is to draw the truth table. Next step is, so truth table is for the required one. Suppose in this video specifically we are going to convert from SR to JK, SR to T. So the required one is the main things, that is 3 things that we are going to have. So that is first we are going to start with JK. So the required JK flip-flop truth table we are going to draw. So the excitation table of the given flip-flop means we are going to draw the excitation table of SR flip-flop. Then we are going to make K-map and we are going to group them and we are going to have the output expressions of S and R. Finally, we are going to draw the output logic circuit. So let's see with the help of the truth table formation and the main things, so that you can understand this flowchart. So remember this thing. So this is the SR flip-flop to JK flip-flop conversion. Means that we are going to have the SR flip-flop. So we are going to pass J and K in this, and we are going to set this SR flip-flop as JK flip-flop. Or we can simply call it as implementation of JK flip-flop using SR flip-flop. So the first step is to draw the truth table for the required flip-flop. So if you observe here, the required flip-flop is here the JK flip-flop, or the building circuit is JK flip-flop. So for that only we are going to have the truth table. So if you see the truth table, this is if you don't know about this JK flip-flop, I am giving the video in the description box. Please check it out, because these are very important or essential truth tables for this video. So if you observe, so draw the truth table for the required flip-flop. So I have drawn all these things. So if you observe the first 2 cases, that is hold condition. So Qn is again replicated as Qn plus 1, the first 2 conditions. So again next 2 conditions are reset, next 2 conditions are set, next 2 conditions are toggle. So Qn is just toggling as Qn plus 1. So for the SR flip-flop only we are going to have the K maps and these and all things. So for that only I am going to have another 2 columns for S and R. So we need to have the excitation table of SR flip-flop, so that we can able to fill these 2 columns with the help of SR means excitation table. So let's see how to build the SR excitation table. So this is the excitation table of SR flip-flop. So if you confuse how to build this, so let's see how to build that. But before we building that, we are going to understand what is meant by excitation table. So excitation table nothing but, so if the output is already present over there, but how it is means how output is obtained when Qn is changing to the Qn plus 1, what is the inputs in that situation. So that is the things that we are going to see. So if you see Qn is changing to means Qn is changing to Qn plus 1, that is 0 to 0. So in that cases we have inputs as 0, don't care. So let's see how to get that. So I am going step by step, so I hope you can understand this well. So if you observe the first 2 conditions, so this is the main characteristic table or the truth table of SR flip-flop. So if you observe the first means the when the present state and next state are 0 0, then if you compare the S and R, so 0 is changing to 0 and R is changing to 0 to 1. So we can simply say that for this situation when present state and next state are 0 0, so S is 0 and R I can say simply don't care. So that only I am representing in the excitation table. So if you see the next case, that when present state and next state are both 1 1, that means that is the last case. Then you can also observe that S and R are. So we have to observe the inputs. So if you observe the inputs, R is not changing, R is 0 0 only. When you observe S is changing from 0 to 1. So we should not consider, or S is don't care and R is 0. So if you observe the fourth case, means the third midterm, that is don't care 0 in the excitation table of SR flip-flop. So for the remaining 2 cases, we need to understand a simple property of SR flip-flop. That is, S means set, R means reset. So this is also known as set reset flip-flop. So if you observe, when present state is changing to next state as present state. If you observe the second case, that is min-term 1, so present state is 0 and next state is 1, means what is meant by that? For the transition, the what is meant by S and R, what are that? So if you observe, is that changing to 0 or 1, we need to observe first that. So it is changing to 1, means it is setting. So set is 1 and reset is 0, means S is 1, R is 0, I can simply say that. So if you consider the M2, the second min term, so means Q is changing from, means 1 is changing to 0. So that is what? It is going to 0 means what? It is resetting. So reset would be 1 and set would be 0. So S would be 0, R would be 1. So that is the remaining two things in the excitation table. So I hope you understood this excitation table of SR flip-flop. So for all these three conversions from SR to JK flip-flop, from SR to T, SR to D, this excitation table is very much important for the conversions. So now we are going to fill this truth table of JK flip-flop so that we can able to obtain the S and R expressions. So if you observe the Qn plus 1 in the JK, means this flip-flop expression means that this truth table. So we are going to compare that and this excitation table of SR. So if you observe Qn plus as 0 0 corresponding, that is 0 don't care SR. So just directly fill the in the JK flip-flop truth table. So in the same way, if you observe the next two means next state is Qn is changing to Qn plus 1 as 1 1. So if you observe in the truth table, that is 1 1 corresponding to don't care 0. So directly fill S and R as don't care 0 in the truth table. So the next case I am skipping because both are 0 0. We have already saw the both are 0 0 cases. That is the first case only. So let's see the next case, that is 1 0. So if you observe the same thing in 1 0 in this here, that is M2 min term in the excitation table. So you just fill directly as 0 1 in the this flip flop as SR. So in the same way, we are going to fill out all the S and R column in this JK flip flop truth table with the help of the excitation table of SR flip flop. So the next step you are going to see is using this. We are going to have the K-map and find the Boolean expression of means existing flip-flop. So means we have to find the S and R output expressions. So let's we are going to use the Boolean algebra, simple Boolean algebra, or we are going to use the means the what we call the K-maps. That is our wish. So simplicity, K-map is very useful, or it is very easy. So we are going to follow with the help of K-map rules. So if you observe, I have two K-maps because for the first column, second column means the S column and the R column. So for the first, if you focused on S column, that is we have two don't cares and two min terms, that is in the 4 and 6, means you can see the sum representation. So that is S is equals to sigma 4 6. So means we have 4 in the place of 4 and 6 we have min terms, and in the place of 1 and 5 we have the don't care conditions. So according to that, I have took the K-map. It is 3 variable K-map because we have 3 variables, that is J, K, Qn. So we should not take the next state, that is Qn plus 1. We should only consider J, K, Qn. So after filling the K-map, you are going to map as the 4 and 6 position as a group. So don't group, don't care. So you are going to have output expression of S as J, Qn bar. So in the same way, if you observe the next column R, so R is the min terms is 0 2 and the don't care condition is 3 and 7. So just fill the K-map and that is 3 and 7 positions, make a group of 2 elements. So you can simply have the output expression R as K, Qn. So finally we have the output expressions S and R. So this is nothing but the inputs to the SR flip-flop. So this is the simple SR flip-flop. So we are going to pass these inputs to the SR flip-flop so that it becomes our JK flip-flop. So let's see how to build the circuit diagram of JK flip-flop with this SR flip-flop. So this is the way that we are going to have our circuit diagram, because the first term is J dot Qn bar. So we should take our Qn bar to because we already have the Qn bar as output. So simply take it as one of the mean feedback. So already we have the Qn. So simply take it as a feedback to the J means K, that product term. So for S we have J dot Qn bar. So take J as input because this is JK flip flop, right? So we have to take JK as inputs. So you have the next product term is K dot Qn. So already we have Qn. So take feedback. Qn means K is the external input. So we are passing external inputs as JK to the S and R as product terms. So this is known as JK flip flop. So if you simply want to say that this whole circuit is equivalent to the JK flip flop. So we have implemented the JK flip flop with the help of SR flip flop and some logic we have used over there. So the next thing we are going to find is the D flip flop, means we are going to build the D flip flop with the help of SR flip flop. So if you observe, this is the truth table for the D flip flop and this is the excitation flip flop of SR flip flop. So we have already covered this excitation table of SR flip flop. So remember, we need for every conversion of SR flip flop, this SR flip flop excitation table we need for every conversion. So what we are going to build? So we are going to build D flip flop. So as we are going to build the D flip flop, we are going to write the truth table of the D flip flop, and we are going to leave two columns for S and R as external inputs. Means we can simply say for the remaining, for the simplicity purpose, means up to now what we have saw, that we are going to make a K map and we are going to solve that, and we are going to have the expressions of S and R, and we are going to have our circuit diagram. That is the procedure, right? So if you consider in the same procedure, so Q and Qn, so we already know a simple situation. In D and Qn plus 1 would be same. So we have already covered this about D flip flop in the previous videos. So please check it out. So Qn and Qn plus 1, if you consider that is 0 0. So again fill according to the excitation table. That is first one. That is 0, don't care. Fill directly there. So the same things that we have already saw in the implementation of JK flip flop. So the same things that we are going to have here. So we are going to compare Q and Qn plus 1 in the D flip flop, and we are going to have from the excitation table that S and R, and we are going to fill this D flip flop. So after filling that, we are going to make K map. So let's see how to do K maps. So because of having only two variables here, that is D and Qn, so remember this thing, we should not consider Qn plus 1. So we should have only D and Qn. So if you have this is two variables, so we should have the two variable K map. For S and R, I took two variable K maps. So the D and Qn as the row and column, if you observe that for some we have the min term 2 and the don't care is 3, make as the group. So S becomes simply D. So R becomes the some min term in the 1 and don't care in the 0 position. So simply combine both of them as a group of two elements. So R expression is D bar. So in the same fashion what we have saw in the JK flip flop, so the same things that we are going to see here. So in the SR flip flop we are going to pass the both of the inputs, so that is D for the S and the D bar for the R, because we have obtained from the truth table and from the K map solving. So simply this is equivalent to the D flip flop, that's it. So simply by applying a small logic that we are going to build, or we are going to have the logic as D flip flop only. Now we are going to implement the T flip flop with the help of SR flip flop. So if you see the T flip flop, so the same way, if T is 0, nothing will change. Present state would be simply replicated as the next state. If T is equals to 1, I am repeating. If T is equals to 1, then toggle will be happening from Qn to Qn plus 1. So this is the property. You can check out our videos in the description box I am giving as well. So T flip flop has a separate video. So from the excitation table, we are going to fill the S and R as the same thing, the same concept that we are going to follow. So the first Q and Qn is 0 0. So from the excitation table, that is 0, don't care. So fill S and R as 0, don't care. So similarly fill all the remaining values. So you can also observe this is the same thing that we are already done in this JK and the D flip flops. So by seeing the excitation table, we are going to fill this T flip flop truth table. So for the output expressions of S and R, again we are going to have the truth means K maps. So if you consider this is also a two variable, so that is T and Qn. So we should not consider Qn plus 1, that is next state. So we have T and Qn over there, and you can see we can make a group of only single element. So we cannot make corner grouping here. That is in the two position. So S is equals to T Qn bar and R is equals to T Qn. So finally circuit diagram would be looking like this. So I hope you know how to build the circuit diagram with the help of the output expressions. So we have the SR flip flop. So we have output expressions. So S is equals to T dot Qn bar. So R is equals to T dot Qn. So simply have two AND gates, and with the help of the Q means taking feedbacks, we can also join both of them as a single T. So this is the thing that we are going to implement the logic, and this is equivalent to the T flip flop. So finally, I hope you understood this video about SR conversion to JK, SR conversion to D, SR conversion to T. So we in the upcoming video we are going to cover with the JK, with the D, with the D. So has separate videos. Thanks for watching up to now.